Good morning everyone. My name is Isha Roy. Today I will present my work on numerical stability in polynomial regression, focusing on comparison between Vandermonde and legendary polynomial bases. In this slide, we will talk about polynomial regression accuracy depends strongly on the chosen basis representation. When high degree polynomials use standard monomials, severe numerical instability often occurs. So the key we investigate is, does an orthogonal basis significantly improve stability compared to standard monomials? In this slide, we will talk about the polynomial regression background. In polynomial regression, the function is expressed as a linear combination of basis function. The standard monomial basis uses simple powers like 1, t square. However, orthogonal bases such as legendary polynomials are designed to be independent on the interval minus 1 to 1. Although both represent the same function space, their numerical properties differ. In this slide, we will discuss about Vandermonde versus legendary. The Vandermonde basis uses simple power of the input variable. As the polynomial degree increases, these columns become highly correlated, leading to poor conditioning and instability. The legendary basis, being orthogonal, has nearly uncorrelated columns and therefore better numerical stability. So our hypothesis is that orthogonal basis improves regression stability. In this slide, we will talk about the data set. To evaluate this, we use Delhi mean temperature data from Delhi from 2000 to 2024. The dataset contains about 9,000 observations and shows strong seasonal patterns. The periodic structure makes it suitable for polynomial approximation and stability analysis. In this slide, we will talk about the conditioning concept. Regression stability is measured using the condition number of x transpose x. As large condition number indicates an ill-conditioned problem where small data changes cause large coefficient changes. We expect Vandermonde conditioning to worsen rapidly with degree, while legendary should remain stable. In this slide, we will talk about conditioning result. This plot shows the conditional number versus polynomial degree. The Vandermonde condition number grows exponentially and becomes extremely large. In contrast, the legendary condition number grows slowly. This confirms that orthogonal significantly improves numerical conditioning. Why correlation matters? The reason for this difference is basis correlation. When basis functions are highly correlated, the design matrix becomes nearly linear dependent. This makes the regression unstable. Orthogonal bases avoid the issue because their functions are constructed to be independent. In this slide, we will talk about basis correlation heat maps. These heat maps visualize correlation between basis function. The Vandermonde basis shows strong off-diagonal correlation, meaning high dependence. The legendary basis shows a near diagonal pattern indicating orthogonality. This explains the difference in conditioning. In this slide, we will see sensitivity to noise. To direct test stability, small noise was added to the data. The Vandermonde coefficient changed by about 18.6 while legendary changed by only 0.06. This roughly 300 times difference shows Vandermonde strongly amplifies noise while legendary remains robust. In this slide, we will talk about the regression fit comparison. This slide compares the regression fits. Both bases capture the seasonal trend. However, the legendary fit is smooth and stable, while the Vandermonde fit shows numerical artifacts, especially near boundaries. This demonstrates the practical impact of instability. In this last slide, we come to the end. This is a conclusion. In conclusion, polynomial basis choice strongly affects numerical stability. The Vandermonde basis becomes ill-conditioned at high degree while the legendary basis remains orthogonal and stable. Therefore, orthogonal bases are preferable for high degree polynomial regression. Lastly, we will show the code to you. This is our code. So, I will like to end my presentation. So, thank you everyone.